Assalamu alaikum dear students. In previous lecture we discussed the square root of negative complex number. Like if we consider x square equals to minus 3, then uh, its roots are x equals to minus iota root 3 and x equals to plus iota root 3, because minus 1 iota root 3 whole square equals to minus iota square and into root 3 square. Now minus square is plus, iota square is simply minus, root 3 square is simply 3. This means that here it is of the form of x square minus 3. That is, this equation or this point x equals to minus iota root 3 satisfies the given equation. Similarly, if x equals to iota root 3, on substituting in this equation we get the identity. Hence these are the two square roots of minus 3. You know that, or root of positive numbers or root of any two numbers a b equals to root a root b. If a is greater than 0, b is greater than 0. This means that if we have two positive numbers, then their square root equals to the product root of square roots. Or if either one is 0, if either a is 0, this means that a is less than 0, b is greater than 0, or a greater than 0, b greater than b less than 0. But we cannot use this concept where we have both number when both numbers are negative, because here 2 equals to root 4. Now root 4 equals to root 2 into 2, or this equals to minus 2 into minus 2, root of minus 2 into minus 2, because minus minus will cancel. Now if this happens, or if this is true for each and every number, that is, if this equation root a b equals to root a root b is true for each and every number, that is for the negative numbers, this means that root minus 2 into root minus 2. Now root of minus 2 is simply iota root 2, and root of minus 2 is again here iota root 2. Now iota is iota square, or root 2 into root 2 is simply 2, that is minus 2. This means that now if root of ab equals to root a root b for negative numbers is true, this means that 2 equals to 2, 2 equals to minus 2, which is absurd. Hence this result is only true when both are positive, or when only one is positive. So we can say that root ab not equals to root a root b if a is less than 0, now b is less than 0. Now you know that in the real numbers we have the equations or the identities, like a plus b whole square equals to a square plus b square plus twice a b. Now here in the complex numbers we can also use this identity or equality, as if we have two complex numbers z1 and z2, then z1 plus z2 square equals to z1 square plus z2 square plus twice z1 z2. Similarly for minus, and similarly z1 minus z1 square minus z2 square equals to z1 minus z2 into z1 plus z2. So this means that for real numbers, that these identities are true, or in set of real numbers we can use these identities. We can also use these identities in, or in set of complex numbers. Now the first exercise of this unit, express the following in the form of a plus iota b. That is, we have given complex numbers, we have to write these complex numbers in the standard form, that is in form of a plus iota b. Now here this 5 iota minus into minus 3 upon 5 iota equals to simply, now this 5 will cancel with this 5. Now iota is simply iota square. Iota square is minus 1. Minus 1 into 3 is simply 3. Now so this means that actually this complex number is purely real. Purely real. So it is imaginary part is 0. Hence we can write this as 3 plus iota 0. Now the second one is iota raised 9 plus iota raised 19 equals to. Now here these two numbers 9 and 19 are greater than 4, so we will simply find it is quotient or remainder, sorry. Now 9 can be written as 2 into 4 plus 1, that is iota raised to power 4 ka whole square, that is 4 2s are 8 plus 1, that is iota. Now iota 19 equals to, when we divide 19 by 4, the remainder is 3, so it is of the form of iota raised to power 4 into 4, that is iota raised to power 4 whole raised to power 4 into iota cube. Now iota 4 is 1, iota 1 square and 1 raised to power 4 is 1, so here we simply get iota plus iota cube. Now iota cube equals to iota square into iota, that is minus iota, simply because iota square is minus 1, so here it is simply iota minus iota. Now it is 0, so it is a 0 of the complex number, or we can write this in the form of 0 plus iota 0. So you can convert, or you can write any complex number in the Citronard form, that is in the form of a plus iota b. Now the second question is, which is on the division of two complex numbers, we have to find the multiplicative inverse. Now if you know that if we have a complex number z, then its multiplicative inverse, if not equals to 0, is 1 upon z. Now here the given complex number is 4 minus 3 iota. Now the given number is 4 minus 3 iota. We know that the multiplicative inverse is given by 1 upon z, that is 1 upon 4 minus 3. Now we have to convert this. This is a complex number. We firstly convert this in the form of a plus iota b. A plus iota b. For this we need rationalization, that is we have to multiply and divide this by 4 plus 3 iota upon 4 plus 3 iota. Now after simplifying this equation and using in the denominator a minus b into a plus b equals to a square minus b square, we simply get, after solving this, we get 4 plus 3 iota upon 25. So this 1 upon z, which is new complex number, which is called the multiplicative inverse of this 4 minus 3 iota, is equals to 4 by 25, because denominator is single, we can break this denominator or we can distribute this denominator, plus 3 upon 25 iota. So here the real part is 4 by 25 and imaginary part is 3 upon 25. Now the second, we have to find the multiplicative inverse of iota. Now iota equals to, let z equals to iota be the given complex number, then its multiplicative inverse is 1 upon iota. Now simply by rationalization, it is iota in the numerator and denominator iota square. Iota square is minus, which implies that iota upon minus 1 is simply minus iota. So the inverse or the multiplicative inverse of iota is minus iota. Similarly, we can find or you can prove that the multiplicative inverse of this minus iota is 1. Why here this minus 1 is multiplicative inverse of this iota? Because when we multiply iota into minus iota, it is 1. 1 is the multiplicative identity, so this means that minus iota is the multiplicative inverse of iota. Now the given number is 1 minus iota raised to power 4. So we have to convert, or we have to change this in the form of a plus b. Now 1 minus iota raised to power 4 can be written as, by breaking this 4, equals to 1 minus iota square whole square. Now using the identity a minus b whole square equals to a square minus b square minus plus b square minus 2 ab, this is 1 plus iota square minus 2 into 1 into iota. Now iota square is minus 1, minus minus cancels, it is minus 2 iota whole square, which is minus 2 square iota square, that is 4 into minus 1, because minus 2 square is 2 4 and iota square is minus 1, which is simply minus 4. So the given this number 1 minus iota raised to power 4 is minus 4, which is purely real, so we can write this in the form of minus 4 plus iota square, because 0 is here, the imaginary part of this, it is purely real. That is why it is minus 4 plus iota 0. So this was about, this first exercise. Inshallah, from tomorrow onwards we will discuss, the properties or the features of a complex number like modulus, amplitude, etc.